Hello everyone. Now we came to experiment number 7, which is Charpy impact test. The objective of this test is to study the impact resistance of metal and also to determine the variation of impact strength with change in temperature. The equipments and tools needed are that I will brief one by one sequentially. That first is we need the furnace, which is induction type. In this we will put our specimen to heat the specimen and to rise the temperature. This is liquid nitrogen pool. In this we will dip our specimen to make the temperature lower. This is vernier caliper to measure the specimens. So these are the specimens, or we call this as a standard specimens given as per the ASTM standard. The dimensions we can see here, like this, its width is 10 mm. The thickness is 10 mm. The length is 55 mm. And these specimens are special specimens. This we called as a notch specimen. It is notched at the center. The depth of the notch is it is 8 mm, means the depth of the notch is 2 mm. So the dimensions are 10 by 10 the cross section, and the length is 55 mm. The notch depth is 2 mm. You can see that we have drilled a small hole at one end of it. The hole diameter is 3 mm. This is just to insert the thermocouple inside this to measure the temperature. This is a tong. As we are doing a Charpy test, so we call this as a Charpy tong. It is a special tong made to perform this particular experiment. Basically, it is useful to hold the specimen in this manner. The width of this tong at this end is same as the width of the anvil where we are going to place the specimen, so that we can make sure that our specimen or the notch is placed properly at the center. This is the thermocouple which we have connected with the multimeter. We will get, this is the thermocouple junction tip which we insert in that hole drilled in the specimen. This will give the readings in terms of millivolt, and we are having a calibration chart which shows the conversion of millivolt to degree Celsius. This is particularly we have taken for a copper constant thermocouple. Before moving to our actual setup, that is impact tester, let me clear that doing this experiment, institute or the department has given some safety measures that we have to follow that safety measures. So the first one is that everyone or each student has to wear the helmets and the goggles. So by wearing these gadgets, we will perform the further experiments. So let's see our actual impact tester now. This is the impact tester of company make Tenius Olsen. This is the pendulum. Pendulum weight is 27 kg. And here is the anvil where our actual specimen will be placed by the tong. This is totally automatic machine. I am having a remote control in my hand. So it says like motor and brake. So if I press the motor, the pendulum itself will go up and latch at the particular height. And after hitting, there is a brake switch. I can stop the pendulum movement. So here we can see the two modes of getting reading. One is digital, one is analog. So particularly we are just following the digital one. We are not taking this analog results. The capacity of the machine is 406 joules. So before doing any test, there is a procedure like we need to test the calibration and friction loss. So to be very precise, let me tell you the calibration is made for the pendulum just to check whether this is freely hanged or not. As I told you, the capacity of the machine is 406. The company had given us the range, like the calibration value can be fall between 20% of the capacity of the machine. If it is not, if that value doesn't fall in that range, then we need to do it calibrate again, or there might be some big issue in this, we need to solve it. Second point is friction loss. As this pendulum is latched at this particular height, we call that as an H1, and it is moving from that certain height to H2. So the air and some another parameters coming into picture. So we need to account that thing. So we are doing the friction loss. Basically friction loss has to be get subtracted from the final value. But in this experiment, everything will be done by the small system. The friction value gets recorded in the system, and when it gives the final value, that is the value already subtracted from the friction loss. So before going to our actual test, let's start with the calibration part. So here you can see we are having some index kind of page. It listed some from 1 to 9. So we are only interested in serial number 2, that is calibration, serial number 8, that is friction loss. After doing these 2 points, then serial number 1, that is our actual test. So yes, so first we will do the calibration, which is serial number 2. I will press serial number 2. The machine itself commands us that what action to be needed. So it is saying me that lower pendulum. So yes, of course it is already lowered. I will press OK. Then it is asking me to latch. The remote control is in my hand. I will press motor. The pendulum automatically will go and latch at particular height. Yes, it is latched. So we press OK again. And now we can release the pendulum. You can see here there is no specimen mounted on the anvil. So we can release the pendulum freely. Yes, the machine has already given the value, that is 3.56 joules, which is acceptable as per the guidance by the company. So here the options are coming like accept or reject. So yes, this value falls within range, so I will accept this value and move further. The second task was, as I discussed, that is friction loss, which comes in serial number 8. So for this friction loss, it is programmed for 11 half cycles. Half cycles means from this 0 position to here it is 1 half, from here to here it is second half. So like this it will move for 11 half cycles, and then automatically it will calculate the friction loss for 11 half cycles. So again it is asking to latch the pendulum. Yes, it is latched, and now it is asking us to release the pendulum to calculate the friction loss. So I am releasing it, and we should not stop this pendulum before 11 half cycles. The machine itself counting the cycles like 5, 4, 3, 2, 1. Yes, it has given the value. The total loss is 23.072 joules and the average loss is 2.0975 joules. We are done with the two parameters like calibration and friction loss. Now we are ready to perform our actual test. So I will go to the serial number 1. And again it is asking me to latch the pendulum. Yes. So here you can see the potential energy, it is showing 407.6 joules when the pendulum is latched at that particular height. So as you can see, I have taken the two specimens, one is aluminum, one is mild steel. This just to show you the difference between two materials at room temperature. But later on, which the second objective, that to see the variation of impact strength with change in temperature, that we are going to do only for mild steel. Means we will break one mild steel at room temperature, one aluminum at room temperature, and then two mild steel at higher temperature and two mild steel at lower temperature. So let's start with the aluminum one. I will hold this specimen by using this tongue. So there is the procedure that we need to insert the specimen from this end and need to bring it to the wall and then open the tongue. So this is a Charpy type of test. In this, the notch will be away from the striking tub or away from the hammer. So our specimen is mounted. So I can release the pendulum and here you will get the energy absorbed by the specimen. Yes. So for aluminum, it has taken 53.04 joules. Now we will go with the mild steel specimen at room temperature. First, let the pendulum latched safely, then only we need to place the specimen on the anvil. Yes, the mild steel specimen is mounted. So let's release the pendulum. So this is the value we have obtained for mild steel at room temperature. I will keep the pendulum latched and we will move on for the temperature variation thing. Okay. So I am placing this two specimen of mild steel inside the furnace to heat it up. I have locked this furnace. I will switch it on. We have set the temperature up to 250 degrees Celsius. So by the time these specimens reach to particular temperature, we will perform the testing for lower temperatures. Okay, so by the time the two specimens get heated, we will perform the lower temperature test. So this is the liquid nitrogen pool. We will insert the specimen by using this spoon. We will leave it for some time to get the temperature drop down. So we will take out one specimen from the liquid nitrogen pool. And we will insert the second one to get it cool by that time. Before doing test, we need to check its temperature, and that temperature we are checking by using thermocouple. I am inserting this thermocouple in the hole provided on the specimen. This reading you can see, it is saying like minus 2.3, minus 3.2. Yeah, here it is saying 3 because we need to change that polarity. So this we can take as an -3 millivolt. Okay, so this is the lower temperature, the first specimen we are doing for mild steel. So I have placed the specimen and now I am releasing the pendulum. Yes, the value comes 5.57 joules. This is the second specimen in lower temperature, mild steel only. Yeah, so this is the second specimen we have placed for lower temperature. I am going to release the pendulum. The value comes 3.3675 joules. Both the low temperature specimens, you have seen that it has flown to the opposite direction of the pendulum. So this may be the Viva question, so be prepared to answer this question. After doing the low temperature test, let's take out the high temperature specimens out. So here the screen is showing 132 degrees Celsius, but we are not taking this temperature because that may not be the actual temperature of the specimen. So before taking out the specimen, we need to switch off the heater and then open the furnace. From this tongue only I am taking out the specimen. Do not try to touch this by hand because yes, this specimen is hot. So we will check the temperature by using thermocouple and then we will break the specimen. The reading is showing something -3.2 millivolt, means the polarity needs to change so that this negative sign will comes positive and vice versa, which we have taken for the lower one. So let's take, yeah, so this is the first specimen for higher temperature. The material is again mild steel. So I am doing this test for mild steel first specimen at higher temperature. The first specimen at mild steel gives the value 124.02 joules. Now let's do the second specimen of mild steel at higher temperature. The specimen is placed and I am releasing the pendulum now. The value comes 136.78 joules. So let's perform the test of mild steel at room temperature. The specimen is placed and I am releasing the pendulum now. The value is 184.83. So here we have completed the experiment required for your lab purpose and also shown you the temperature variation. Thank you. So these are the broken specimens which we broken just now on the impact tester. This one is mild steel and this is aluminum. You can see that both of them not have broken completely, and by seeing the grain structure or the fracture surface, you can tell that whether the fracture is ductile or brittle. Adding to this, I am having one sample of this was the higher temperature and this was the lower temperature. So in high temperature we can see the grain structures, they are very dense and dull in color. Whether in the lower one you can see the grain size are very fine and shiny in nature, and this higher temperature specimen is not also broken completely. Whether in lower temperature it is totally broken as it has taken the lesser energy to break. So by seeing these fracture surfaces, we can be able to conclude that whether the failure is ductile or brittle. So at this point I can say that we are in position, like we have seen the impact testing and also the variation of impact resistance with the temperature to fulfill the criteria for this course. Thank you.